A projectile is launched at a certain angle. After 4 seconds, it hits the top of a building 500 meters away. The height of the building is 50 meters. At what angle was the projectile launched? All right, what we're going to do is draw the picture first. We have a building here, and the building is at a height of 50 meters, but someone is 500 meters away from the building, and they're launching an object at some angle theta, and this is 90 degrees. So our V naught is here, and this is in a time period of 4 seconds. All right, we're going to analyze V naught. V naught is here. We're going to put V naught x here and V naught y here with some angle theta. Sine theta is equal to opposite over hypotenuse, so V naught y divided by V naught, and V naught y is equal to V naught sine theta. Cosine theta is equal to V naught x over V naught, so V naught x is V naught cosine theta. And now we're going to do something a little different. Tangent theta is actually going to be equal to sine over cosine. But in this case, we're going to write V naught sine theta over V naught cosine theta. Because V naught cancels with V naught here, you're left with tangent theta as sine over cosine. Now, V naught sine theta is V naught y. So if we find V naught y, we have V naught sine theta. If we find V naught x, we have V naught cosine theta. So we can plug in those two numbers for here and get tangent theta, which gets us an angle. So, the distance in the x direction, we know. Distance in the x direction is equal to 500 meters. The time in the x direction is equal to 4 seconds. So t is 4 seconds. Distance in the x direction is equal to velocity in the x direction times time. So Vx, which is really Vx naught or V naught x, is equal to distance in the x direction divided by time. So Vx is equal to 500 divided by 4, which is 125 meters per second. All right, now that gets us V naught cosine theta. V naught x equals V naught cosine theta. V naught x is, or Vx naught, whichever one, is Vx, which is 125. So we know that this is 125. Now we just need to solve for V naught sine theta. Now this is a kind of a math trick, but earlier we learned that YH is equal to V naught sine theta t, V naught sine theta t minus 1/2 gt squared. And we're actually going to be solving for V naught sine theta. So we're not solving for theta or V naught individually, we're solving for the whole thing grouped together. The maximum height, YH, is 50. So that's 50 is going to be equal to V naught sine theta. Our time is 4 seconds minus 1/2, 9.81 times 4 squared. In this equation, you only square the time, don't square anything else. So this is going to be 50 plus 1/2 times 9.81 times 4 squared, all divided by 4, and that's equal to V naught sine theta. When you plug this in your calculator, V naught sine theta is going to be equal to 32.12. And plugging this into tangent, tangent theta is equal to 32.12 divided by 125. Dividing that out, that gets you 0.25696. Theta is equal to the inverse tangent of 0.25696. And theta is going to be equal to 14.4 degrees. And what this means is that if you have a building with a height of 50 meters, and you're standing 500 meters away, you launch an object, it takes 4 seconds to get to that object, this angle theta has to be 14.4 degrees.